Next, for our project settings, we have our Physics Manager. And inside of our Physics Manager, we are able to define the different behaviors of our objects within our world. This is going to be the physics behaviors of our objects. We have things such as gravity, where we can define how much gravity is applied to the rigid bodies in the world, to our default material for physics materials that we can apply to an object. If it has no physics material applied to the collider, we could apply one by default on a global scale. We have things such as our bounce threshold, and these allow us to define how much velocity two objects impacting with each other can have before the object actually does not bounce. Other options in here that have some importance to us would be with our min penetration for penalty. This is going to be something to say how far are two objects allowed to collide in between each other before they need to be pushed away or apart from each other. Then we have things such as our solver iteration count. This is an important one where we're trying to improve the quality of our physics. So, for instance, with our solver iteration count set at 6, your best options are always around the 6 to 7 is a good count. Now, if you're trying to improve, let's say, the quality of our joints, the quality of the contacts, then you can always increase the solver iteration count. You can bump that up. Now, the higher you go with this, the smoother it's probably going to work, especially if you're having some problems where something's really behaving erratically, it's twisting or bouncing in a way that it's not meant to do. Then increasing this can help, but the higher we increase this, the more processing power it's going to take to actually figure it out. Now, below that, we have an option for a raycast hit target. Now, with this option enabled, a raycast that's going to intersect with a collider marked as a trigger will return a hit. If it's disabled, these interactions, these intersections, they will not return a hit. So this just allows us on a global level to set that. Below that, we have a layered collision matrix. Now, this is an interesting little thing. This allows us to define how the layer-based collision detection system behaves, how it works, by setting up our own matrix. So you can see in here that we've got our rows and columns set up with our water, our ignore, our transparent, our default, and each one to help find out how does it figure out what it's going to collide with and what it checks first and last.